So the last thing to go over are periodic trends. Okay, so what I'm going to do is this. Let me sort of define some of these. Um, let's talk about atomic size, right? This is literally like the diameter or radius, depending on what you want to look at. Now they're both going to be like related to each other, but the atomic size or radius, right? Usually done as a radius or diameter, is how big the atom is. In essence, it's how far out are the furthest electrons. Ionization energy is the energy required to remove an electron. Let me just zoom in and do this. Required to remove an electron. I don't know why I was spelling electron like that, but I was. Electron. Okay. Metallic character, right? Well, that's a weird one, actually. It's how metally it is. So we talk about general metallic properties like conductivity, conducts electricity, malleable, ductile, shiny, right? Things like that. And so this is has to do with the properties of metals, which you should know. And then the last one last thing, oh, actually, those are the only three we talked about here. The last thing to talk about, which is the reason why all these things exist, is really just Coulomb's law. So think about Coulomb's law. Remember I talked about it. It's that the idea that oppositely charged objects are attracted to each other. So if the charge goes up, increasing charge, oh, I wrote it already down here, right? Means stronger attraction. And this has to do with opposite charges, okay? You know how we say opposites attract, so oppositely signed charges like plus and minus. So that oppositely charged objects. And then the distance separating, right? So you know the saying, absence makes the heart grow fonder, right? It's not true in atoms. So if, I don't know, and you think about humans, it's not true for all humans either. But if you have a positive and negative charge, the force of attraction gets weaker as you pull them apart from each other. So the further they're separated, right, the weaker the attraction. So as distance increases, the strength of attraction is weaker. So weaker attraction. Let's write it consistent here. Okay, so just very quickly, if we're talking about a longer group, right? So it turns out when you go to the higher energy levels, you're going further away from the nucleus. And you get that idea from Bohr's model. So, for example, if this was on a relative scale, let's say that was sodium, right? If I go to rubidium, it's bigger, like that. So just point out to here, right? Here's sodium at the third period and rubidium down at the fifth period. So we're going to higher energy levels and the atom gets bigger, right? So what this means is the attraction is decreasing because these electrons that are on the outside are further away from the nucleus. That's where the positive charge is. So I have this positively charged nucleus in here. So this is plus, and then the negatives are out here. So as you go down this way, the attraction gets weaker, right? That's one thing. And you're just going into bigger orbitals. So these, right, these are larger as you go down, right? Now, if you're going up, it's getting smaller, so it's just the opposite. Now, if you're going along a period, that's left to right on the periodic table, right? I have a trend that actually looks like this. I'm on the left side of the periodic table, and as I go to the right, it's going to go like this. So the question is, And that's like a little bit of an exaggeration, but not too much of an exaggeration. Why is it getting smaller, right? So these are all in the same energy level. So along a period, same energy level, roughly. But what you're doing is you're increasing the number of protons in the nucleus. So the proton charges, right? Nuclear charge increases. Increases. It's a good thing I say these words. And so the result is, as you go from left to right, it gets smaller, like this way. So even though their masses go up, right, they get smaller, so their densities are climbing very quickly as you go from left to right on the periodic table. Now, having said that, we'll talk about ionization energy, right? So if the electron is close to the nucleus, or if the nuclear charge is high, the ionization energy will be high. So I'll write that out, right? If you're close to the nucleus, ionization energy, I'll call this IE, so I don't have to write it over and over again. IE is high if, right, the radius is small, or the nuclear charge is stronger. Okay, so think about what we just talked about with radius, because all of these things can be sort of related together, right? So if you're going along the period, going from left to right, the nuclear charge is increasing, so we would expect, and it's true, this is what happens, this is increasing IE. Now, if you're looking at a group, right, I'm going to do it this way. You're going from large to small, right, as the electrons get closer to the nucleus, right, they're closer to the nucleus, so they're more strongly attracted, and they have to be pulled to get one out. It's like you're reaching down in a well, and you're having to pull it out of the well, right? So increasing for the ionization energy, like that. So increasing ionization energy going up as you get smaller, and increasing ionization going right. Now, for metallic character, metals, one of the reasons they behave like metals is that they're very good at sharing their their um, um, electrons. And if you think about what's happening with ionization energy, right, the place they would do the best at sharing electrons would be highest, most metallic character, right, at the bottom of a group. And also to the left, like this. So I usually make this summary chart as kind of a very simple chart. This is my periodic table. I'm going to draw it like this. So right, it's not even looks like a periodic table, but you get the idea, right? This is the bottom left is down here. The trends go like this. That's the way I'm going to summarize them, okay? And then, or a diagonal, so like that. So I have highest. Well, let me start with smallest radius. Highest ionization energy. Least metallic. And then on this end of the periodic table, down at the bottom left, right, these are the largest down here. They have the lowest ionization energy and are the most metallic. So that kind of summarizes all the periodic trends you need to do. Understand, you should go in on the practice test for this chapter. You should go find some of those problems and work them out. Okay. Again, if you have any questions or you want to go over this in office hours, remember I'm doing office hours a couple times a day during this 4-week session. If you're not in the 4-week session and I just reused this video, it's whenever I said it was. But if you're in this 4-week session, there's a couple office hours a day that you can sort of drop in and meet with me online and go over these ideas.